Hey guys, it's Jimmy here from Unstoppable Domains. First of all, I just want to thank everyone at SmartCon who's put this together, and I want to thank Chainlink for inviting us to speak. We actually had my colleague and the co-founder of Unstoppable, Brad, up earlier talking about a little bit more of a high-level overview of what Unstoppable does, and I thought I'd take this time to maybe go into a little bit of a deeper dive of what Unstoppable looks like underneath the hood. And I thought it'd be really fun for me to talk a little bit about a pretty specific use case that we've built that actually relates more closely with Chainlink. And that has to do with social verification with your domain name. But before I go ahead and get started, I'm going to do two things. One is I'm going to intro myself so you know who I am and what I'm doing. And then the second thing is, so me, I'm Jimmy. I am a product manager at Unstoppable, and I lead a team called DevTools. And it's really fun because I get to do my favorite thing, which is make our product more useful and also interact really deeply with the crypto community in order to embed our product with a series of other products. And so that's why I've had a ton of fun working with the Chainlink team and actually embedding this new feature, and really excited to show you guys about it. And so that's me. So what we're going to do for the next 28 minutes or so is we're going to essentially talk about three things. One is I'm going to talk about what this feature actually is in terms of social verification for decentralized domains. The second thing is I'm actually going to talk about what is the experience behind actually getting social verification set up for your domain name. And then lastly, we're going to peer underneath the hood, and I'm going to show you exactly what happens in terms of smart contract interactions and a bunch of different processes that users need to do in order to actually get this identity verified on chain. And then I'm going to leave a little bit of time to talk about extensions of this, because this is just one of many use cases for social verification using off-chain information with Chainlink. And so I definitely invite anyone else to build kind of on top of its existing framework that we put together. And so this was just for Twitter. And so you can see this kind of expanded to n number of use cases. So definitely pretty exciting stuff. Cool, let's go ahead and get started. And so we kind of call this feature the Twitter verification system. And it basically extends the Chainlink Oracle network in order to extend and support an entirely new class of use cases that we call social verification. And so for the Twitter use case, you can see here that Brad is tweeting on his Twitter account, hey, I want to tie this to my domain name. That's actually recorded within the Chainlink network of oracles. It's also validated on chain through a smart contract that we deployed on Ethereum. And then lastly, it's tied back to an unstoppable domain. And therefore, it's kind of intricately linked, where now your decentralized domain that you own forever, as Brad mentioned in his talk, is also tied to some form of Twitter verification. And so there's kind of two pretty interesting use cases for this. One is if you want to send payments to someone, this is a level of confidence that you can get that this person is pretty legitimate if they were able to tie their Twitter account to it. And so whatever reputation that you've built on Twitter is also translated to an online payments use case. The second kind of use case is a little bit more broad, and that's more around the idea of social verification. And so when you think about our identities online, they're kind of disparate. And so you might have an identity on Instagram, on Discord, Twitter, YouTube, TikTok, what have you. And they're kind of all floating in different places. And I imagine, we're all wearing kind of different faces or showing different parts of our identity online. And so not one place is kind of the canonical place that we can point to for anyone to know who we are online. And so to be able to actually tie all those disparate parts of our online identities together under one username, which is our decentralized domains, that could be a pretty powerful use case. And so that's kind of at a high level what this is. And we're pretty excited again for the possibility to extend it to n number of other kind of social verification formulas. So what I'm actually going to do is show you kind of what is happening in action. And so right now I'm on my Ether wallet, who has integrated this feature. I'm actually going to send some money to a friend. And so I'm going to send 0.1 ETH to my friend Mago. And we see here that when you enter in Mago's domain name, which is mago.crypto, two things kind of pop up. One is his ETH address pops up, so his 0x address that he tied to his domain name. And the second thing that pops up is his Twitter verification. So I can click here, see that we're already following each other, but he's also just a real account. And so that gives me a level of confidence that I'm sending it to probably the right person, because he's going through that effort to actually link his social identity, or at least a part of it, to his domain name so that we can do payments. And so this is kind of a interesting use case because there's a layer of anti-Sybil resistance underneath it too, where you're not just sending it to a random person. You're hopefully tying it to a real person online, or a real person offline rather. And so this is kind of a step in the right direction. And so how this works underneath, so that's basically what's happening, at least from a client perspective, when we're doing Twitter verification. But what's actually happening underneath the hood is pretty complicated. And so I'm actually not going to go through this because it is quite dense, even for a technical audience that's interested in this. But what I will do is kind of highlight the left-hand side to show you exactly what's kind of happening in order to actually verify your Twitter account and tie it to your centralized domain. So the first thing that you're doing is enabling Chainlink, which is this button right here. And what does that mean? That means you're giving the permission to the Chainlink network to post verified data to your domain. And so I mentioned before that Unstoppable deployed a smart contract on Ethereum. We call it the Twitter verification operator. And so what you're doing is you're essentially approving the smart contract to make changes to the records tied to your domain on your behalf. And so that's what the signing request here is for. The second thing you need to do is just tweet in order to validate. And so you're doing kind of a generic tweet that has two pieces of information. One, it has your domain name. And secondly, it has this verification hash that will be read from the Chainlink Oracle network and eventually tied back to your domain name on chain. And then lastly, what's happening is you need to pay the Oracle to verify the tweets. And so again, it goes back to that same smart contract, the Twitter verification operator. And we're actually going to be diving in that smart contract so you can see some different parts of it. But essentially, it's doing bidirectional verification so that your Twitter name is tied to your on-chain domain identity, which is pretty cool. And so at a high level, that's kind of what's happening under from kind of like a verification perspective. And what's actually happening is basically the Twitter verification system consists of an external adapter and external initiator for Chainlink nodes that supports the validation of Twitter accounts on Ethereum. I'm just going to turn back this little icon here so you're not staring at this kind of like really complicated page. So that's essentially what's happening, right? It's using the Chainlink kind of node operation system for validation of Twitter accounts. And so like I mentioned before, the goal here is to really create bidirectional verification on chain. And so when users post their verification info on Twitter, linking their domain name with some sort of hash to identify them, the Chainlink network posts this verification information, linking the Twitter account to a domain name on the blockchain. The signatures can then be checked on chain, and the tweet can be checked using the Twitter API with that unique hash in order to confirm the association. And finally, there is verifiable attestation that there's a link between the domain and the Twitter handle. And so pretty simple, right? When you look at it kind of underneath the hood. And so let's actually kind of see this in action. And I'm actually going to use a domain name that hasn't been verified by my Twitter yet in order to show you guys, again, what's kind of happening from a technical perspective. And so here I'm on Unstoppable Domains, and I'm actually going to go to one of the domains that I own. And so again, I own this, and it's living in my non-custodial wallet. And so therefore I have write access in order to actually add different records to it. And so you can add crypto addresses like Bitcoin, ETH, what have you. You can also add a website. And so you can add an IPFS hash in order to resolve to some sort of decentralized content. But right here, I'm actually going to go to verify. And this is the tab that is going to allow us to, at least for now, just verify your domain with Twitter. And so the first step that I kind of mentioned from that diagram was giving permission to Chainlink to post data on your domain. I already did that because it's kind of a long process. So that is not fun to look at a live demo. But if you were to go on this and you haven't done this before, there should be a button here that says essentially, allow access or approve access to Chainlink. And you're actually going to, inject web3.js into the page. You're going to need to sign with whatever non-custodial wallet you have, whether it be MetaMask or Rainbow or another wallet, in order to, allow access again to the token that you have in your wallet. And so what does it mean to give permission to Chainlink? So when users gave permission to Chainlink, they're essentially allowing the network to post records of their domain on their behalf. But they're actually doing it in a very bounded way, because if we're just allowing the network to post whatever records, that is kind of a security concern. And so what they're actually doing is approving the Twitter verification operator smart contract that I was mentioning earlier. And so in order to do that in a bounded way, we're actually using the permissions of the ERC 721 standard, which is the pretty common NFT standard that I think a lot of art projects use, and also that our domains use. And so with these permissions, we actually let users delegate domain control for records to be written by other entities, whether smart contracts or other users on a user's behalf. In this case, again, we're allowing that Twitter verification operator smart contract, sorry, just such a long name, in order to do so. And so currently what we're doing is we're using a set approval for all call to make a one-time call to enable Twitter verification for the domains that the user owns. And so that's why this button doesn't appear for me anymore in our UI, because I already did it for one of my domains that I own with my ETH address. And since I own all my domains on the same ETH address, I don't need to do that approval anymore. It's just something that I did in the past. And so once I made that one-time call, everything is approved. And again, when you're making this call, I'm not directly permitting the Chainlink network to make updates on the domain. Instead, what I'm doing is I'm giving permission to a specific smart contract, in this case, the one I mentioned, that has limitations on like what can be updated on the domain. And so now what I'm going to do is actually go into the smart contract. And so here on Etherscan, and this is the smart contract address that we've deployed on Ethereum. And so I'm going to peer into the code, and pretty deep in here, but when we go to line 721, you're seeing that we have a function called set validation. When you're seeing is actually some of the stuff is hard coded. And so we hard code this because that allows us kind of like that bounded ability to just set certain parameters and change them. And so for this case, for the set validation function, we've only allowed the setting of Twitter fields and of the social.twitter.username and the validation.social.twitter.username fields. So you can see them right here. I think I highlighted it. Oops. Yeah, I'm going to re-highlight it here. And so these are the only things that basically you're allowing the Chainlink network to make updates for. And they're going to tie that record back into your domain name. And so when you want to conceptualize it from kind of like a metadata perspective, you kind of have this overarching key. So in my case, Jimmy 0xjim.crypto, and underneath you have a field for social.twitter.username, and only that field can be changed by Chainlink. And so, we were really mindful about kind of the permission rights of this kind of delegated record management for your domain name. Cool. So after I allow Chainlink to do that, the next thing is obviously to tweet a verification post. And so, once we give them the permission, I'm just going to need to tweet this. And so I'm going to send a standard tweet that's basically containing my domain name and a verification quote that the Chainlink Oracle is going to look up. And so I'm literally doing this live. And you can see here, we kind of have this boilerplate tweet that we put up here with the button. So I'm just going to tweet this and throw it out into the universe. And so again, we can just see it has my handle here, 0xjim, going to be verified by Chainlink. And here is the hashtag with the verification code that the Oracle is going to pick up. And so after I have sent the tweet, now I'm going to make a call again to the same Twitter verification smart contract to request that the Chainlink Oracle validates this tweet. And so I'm going to do that in a sec. But before that, I'm going to talk a little bit about what's going to happen when I click this button. So to make this easy, we've essentially embedded the flow inside of the link token. And so the link token has an ERC 677 standard with a function called transfer and call. I'm actually going to go into the smart contract and show you guys transfer and call. Yeah, address right here. And so what's happening here is because of the ERC 677 standard, we can allow the link token to essentially be transferred to smart contracts and trigger some logic within that smart contract. And so when we transfer link, when I click that button to the verification contract, then it'll call the on token transfer function as a callback. And then it's going to register a request into the Oracle. And that's why we send link as part of the flow. And that's why when you saw in this UI, it says enabling with Chainlink requires this much link. And that's because we're sending link in order to actually make the call to the Oracle network. So I'm going to do that right now. So yeah, I'm just going to sign with my MetaMask. I don't think you guys can see, but it's pretty standard. So, you know, oh, okay, there's some two-factor auth that's needed. I will do that. And that's why I'm happy. I only shared one tab of my Chrome. The beauties of doing it live. I definitely have link in my balance, so I don't know what's happening. Let's try this again. The beauties of doing it live, guys. But I wouldn't have it any other way. All right, you know what? I'm going to spare you guys from the debugging. The demo gods were not on my side today, but you kind of get the gist of it. So what's happening is, you know, after you send the link to the smart contract, the Chainlink node is listening for any sort of requests on chain, and so we send the link token to the smart contract, and we make a call to the on token transfer function. And an event is created and recorded. And then what happens then is the operator then extracts the data from the event. And so it's we're essentially feeding it two things. We're feeding it the domain name, or in this case, we're feeding it the token ID of the ERC 721 smart contract that we deployed on Ethereum. And we're also feeding the Twitter verification code. And so then the Chainlink operator searches for the tweet with the verification code using the Twitter API. It compares the tweeted domain with the domain that was recorded on the event on chain with the smart contract. And if they match, then it's verified. Afterwards, the Chainlink node signs this message with an attestation that the handle and the domain are indeed matching from the tweet. Then the operator broadcasts to the verification contract, writing the Twitter handle and signature to the domain's record field. And so it's updating that field that I was talking about earlier, Twitter, what was it? Social.twitter.username that was on the smart contract here. Where was it? Yep, right here. Cool. And then, you know, afterwards, what happens then is the operator then broadcasts the verification that those two things are actually linked from off-chain and on-chain information. And the Oracle claims the link as payment. And then it goes back, and again, the record is updated on your domain name. And yeah, finally, you're good to go. Your domain name is tied to your Twitter username. And so that's kind of what's happening underneath the hood. When we look at it from a client lookup perspective, that's basically how you actually get this interface to show up within certain wallets or other clients. So when a user types in a domain name, this client can now check for Twitter account verification, which we actually embed into our resolution libraries, which are available on our docs page. And you can also find it in our GitHub. But they're checking for Twitter account verification, and then ensuring that the signature on the Twitter records is from the Chainlink Oracle, and that the Twitter handle records the blockchain domain, and that the Twitter handle records that are on your decentralized domain match the Twitter records from Chainlink again. And then there's also a bit of client-side validation that any client can do to ensure that users always check the validity of the data. And so they include an on-chain signature from the Oracle, and they can actually check to see if this is valid. So they're not actually trusting our libraries in order to say that this is true. They're actually doing client-side validation with the signature that's provided by the Chainlink Oracle. So that's pretty cool, right? That's truly trustless on various levels. It's not just checking the domain, but it's also checking or rechecking rather the information off chain from the Chainlink Oracle. So that's really awesome stuff. So that is basically what's happening underneath the hood for our feature. And so, this is really awesome because, again, you're tying real world identity, or in this case, Twitter, to the blockchain. And to the best of my knowledge, this is one of the first times that I've seen this use case added. So it's pretty powerful. But you can imagine this, getting kind of extended to a bunch of other different things. And so one thing is, like what I was mentioning before, you can tie other sorts of real world identifiers, and you can bundle them all into one canonical kind of like key that you can tell a bunch of people. And basically, it's kind of just like your self-sovereign identity that you can share with anyone, and it attaches all of your kind of disparate social identities. So that's pretty cool, right? I can tell people xerxgem.crypto. They can, they can hit the smart contract that contains it, and then, any sort of arbitrary metadata can be returned, whether it be my Twitter handle, my Instagram handle, my Discord handle, my YouTube name, what have you, right? And so that's pretty interesting from kind of like a social identity perspective. But what's, I think, arguably more interesting, although that was already pretty interesting, arguably more interesting is future areas of exploration where you are still adding either real world identifiers or really important real world information to your decentralized domain name. And so one idea is, not only working with, kind of like crypto native apps for information, but you can also work with kind of like larger Web2 companies. And so anyone that really wants to add this kind of like functionality or application can definitely do so. They can deploy, a pretty similar smart contract to what we deployed, but it's essentially just reading a different set of information from some sort of off-chain source through Chainlink. Or, these companies can become Chainlink oracles or Chainlink operators in themselves. And so you can start feeding some pretty interesting Web2 information to it as well. And so one thing that I think is pretty interesting is the potential for like financial information or other kind of like PII information to be brought off chain, on chain, and tied to your record in some sort of like privacy preserving way. And so you can add like KYC from a Web2 company like a fintech or like some sort of bank. You can add in credit scores from, if you're America based, all the credit bureaus, the three credit bureaus that are kind of like the canonical source of credit scores for Americans. You can also add electronic medical records. And so that's kind of far out there, but you can see a world where if you want to, have kind of like a source of truth for all of your medical records and you want to share it with your physicians, you can do that. And the hope is you can do it in a privacy preserving way where, you're sending this information, not everyone can really read it on the blockchain. And you can permission access to who can read it. And so you're sending this information, no one, no public person can really just like read your medical history. Or also what's interesting is, especially if you're in America, like no payer or insurance provider, that's what they're called, can read it either. And so you kind of have a lot of power over what information you want to share with physicians versus what information you want to share with insurance companies, because if there was kind of information parity there and you have maybe like a pre-existing condition that isn't covered within the realms of the law, you might get some pretty egregious kind of like premium charges from these insurance companies. And so that's personally something that I'm excited about. And obviously you can tell because I'm rambling about it, but you can do a lot of pretty interesting stuff. So yeah, that's kind of like at a high level what's happening. And in order to actually extend it, again, there's kind of like two pieces to it. One is you want to deploy a smart contract on Ethereum that looks pretty similar to ours. Like you can definitely fork ours and kind of like change a few parameters, but obviously more than just that, because you're reading essentially a different data source. And the second thing is you're allowing the permission to change a record on your domain name for a different field, right? And so you're going to need to change the field. Let's say, let's do a GitHub example, right? Like let's say there's some way for you to link your GitHub handle to your domain name. And so you would want to take the smart contract. You would want to add a new field within the domain record metadata called like social.github.username. And then you would want to work with the Chainlink Oracle network in order to actually record some commit or maybe some other way to record a transaction on GitHub and tie that back into your domain name. And so that's just like a specific example. But you can see a bunch of other ways in order to tackle this. And so we've done Twitter. We think it's kind of like a helpful kind of like framework for a lot of other people to get started. But like what Brad was mentioning in his talk, like we can't do this alone. And that's, the best part about working in crypto is it's a community and people are always really, really smart people, and devs are always looking for novel innovations. And so that's kind of like our call to action a little bit from this is like, we would love to see other people building really interesting ways of doing social verification with Chainlink and tying back to a domain name. Cool. That's it for me. Thank you.
All right. Thank you so much, Jimmy. And thank you again, Brad.